what is DevOps? Well, the funny thing about when you say what is DevOps, you ask 10 people what DevOps is, you're probably going to get 20 different answers, right? But at Microsoft, DevOps means something very specific to us. DevOps is the union of people, process, and products to enable the continuous delivery of value to our end users. And now notice I said that really, really carefully, right? And the reason why is because, well, one of them, that definition was created by my manager, so if I get that wrong, right? The other thing is because every word of that was designed very specifically, right? The key is we want to continuously deliver value to our end users, and this is vital in today's world.
Hey everybody, it's Jay. Welcome back to AzureFunBytes. I'm just having a little dance here to my own song. Why not? So, it is just a few days before Halloween. I've got my typo negative shirt on because I'm in a spooky mood. And I bring along to you a spooky friend today. And my spooky friend is going to help us learn a little bit about observability and monitoring. And we'll do it on Azure using some tools that he'll teach us about. But before we get this, we're going to talk about what exactly the product he's going to show us. And so let's do that. I'm going to show you this really quick, and then we're going to meet our guest, Austin, okay?
Observability is not just knowing the problem is happening, but knowing why it is happening and knowing how I can go in and fix it.
We have logs, we have metrics, but as we look at distributed systems like microservices, containerized microservices, really, like there is this thing that's missing, which is understanding interactions between these services.
Now we get full visibility across our entire lifecycle.
A distributed tracing solution like Lightstep was kind of this missing tool in the toolbox.
So we have about a little over 100 services in production today at 5 different languages. How do you scale that out in an organization? How do you manage having different libraries and all those different systems and being able to rapidly develop in those?
One of the things that Lightstep and the tools that we're kind of adopting is helping us get to this place of what is the user experiencing and how does that affect the decisions that we make. We came from a very traditional APM format. The old tools, the old school kind of tools that we had, there's no way to find that out.
With a log-based solution or maybe metrics, you might get a clue that there is some question to ask or something to interrogate about the system you're looking at. Like with Lightstep, you can almost immediately drill down into it. So it's this difference between never finding the problem or never really being able to understand what's going on and instantaneously seeing all of the relevant information.
We did a deploy, and because of the near real time of what's showing up in our dashboard, we immediately saw these handful of weird outliers. Yeah, there actually is an issue there, and then it just drove us right to where it was.
And so Lightstep saves you a ton of time.
It's really neat to be able to then go in Lightstep and see the whole service graph visually displayed out. That's very helpful because it allows us to very quickly then immediately go to the target problem rather than having to piece that through numbers and metrics on a graph. And we really didn't have that visibility, even with our Zipkin infrastructure prior, that we have now with Lightstep.
I think it is critical that we care about the actual end user experience, probably more so than anything else. And Lightstep has been instrumental in that because now we can say, from all the way to the front end of the UI, all the way through the API calls, all the way through the back end, we can trace out that entire experience.
And so, to talk about Lightstep, I've got my buddy, my partner in crime. We do something else in. We don't do too much crime, but it feels like crime at times.
Yeah, it feels like crime.
Austin L. Parker, or on Twitter, or just Austin as I know him. Thank you very much. You are a developer advocate over at Lightstep HQ. We're going to be talking about Lightstep and how that product is going to help us get a deeper look into things on Azure.
Yeah, cool.
Hey, how's it going, Austin?
Pretty good. Another brisk, kind of damp day outside, but feeling very spooky. And
the weather's pretty much the same here. So
yeah,
it's pretty gross. But one of the things that I'm doing my best is making the best of it here inside, trying to get a little bit of stuff done, and keep a little dry in the process. So
Yeah.
that's me. Everybody cool back at home? I know you've got a little one there or something. Am I right?
Got a cat.
You got a cat. Yes, a cat there. Yes, sweet. I
Cat's
have a
doing
little
fine.
one. I have a little one as a dog, and she is ridiculous. I believe you're fairly familiar with my insane dog, Meadow. She's a
Yeah.
very lovely little dog, but she is pretty friggin' crazy, which makes her very, very wonderful to be around. But, we learn something when you adopt a dog. You always
Yeah,
learn
it's
things.
so a new pet is always a challenge
Yeah.
but it's the joy of learning how they work and them learning how you work and
Yep. So I'm going to ask you, before we kind of get into what we're doing,
Mm-hmm.
one of the things that I know you did that I was really super impressed with, and I think it's making the best use of a situation that we're all in. You did something called Deserted Island DevOps. You want to talk about it for a second?
Sure. So Desert Island DevOps is, to my knowledge, the world's first Animal Crossing based DevOps conference. It was earlier this year. It was in, April 30th. And we had about maybe 8 speakers. And it's kind of like if you've ever been to a DevOps Days,
Mm-hmm.
if you've ever been to just a community DevOps event, it was kind of like that, except that all the speakers came to my Animal Crossing island, and we streamed it all we streamed it all out live on Twitch. We had a Discord; people could ask questions. There was a lot of great interactivity with speakers in the audience, and everyone basically said, "Hey, this feels like a tech." Everyone was like, "Oh, I needed this," right? So we've done some other events with that over the summer. I see Jay's pulled up the website here. If you want to check out the videos, you can find them.
Here
I
on
think
the
the
On Call Me
YouTube.
Maybe, right?
Yeah,
Or
so
not?
On Call Me Maybe is our Twitch channel. I haven't been streaming too much recently, but if you go to our
Okay.
YouTube, that's
Sure.
where all the videos are.
Let me take a look. So yeah, I'm sure you all can find it. It's up here in the chat. If you have any questions about doing an event like that, feel free to ask us as well. We got a really cool opportunity, Austin, to kind of look at some tech today.
Yeah.
Maybe talk about how the tech that I help advocate for and the tech you help advocate for can kind of work together to make things a little easier for people. And I
Yeah,
think
totally.
ultimately that's what we do in like developer advocacy, developer relations, whatever you want to call it nowadays. We're all about just making sure people can understand how these things work and how they'll work with other products to make it easier for themselves.
Yeah, totally.
To do really. So I'm going to bring up this and to get kind of started, one of the big subject we're going to talk about today is around monitoring and around observability, and they're two very, very different things. And so what I'm going to get started with is something really simple. I've built a Kubernetes cluster. I'm going to go ahead and go to my resource groups. I'm just going to reduce my scope. And then I've got this FunBytes number 19. And I'm going to try to make it so it's a little bit more visible for everybody and you can see all the different things. So Austin, one of the cool things that Azure has built natively in, and you can tell me a little bit about like how we get a little bit beyond this.
Mm-hmm.
Azure has a number of different ways of storing insights on your application. Specifically, we're talking mostly today about Kubernetes. So if you're watching and you need to know more about Kubernetes, there are previous episodes about using containers, using Kubernetes. There's a ton of docs that I've done on it. Please check that out. If it's a little above your head today, don't worry. We're going to keep it pretty simple. What we're going to do is just tell you that these things exist and how that they can work together so that you know what's going on. Because Austin, here's the thing for me, and you can tell me about your own experience. One of the most difficult parts about running applications and especially at scale, is knowing what's going on all over the place and be able to ensure that you have enough infrastructure, the right infrastructure, so that if a part fails, that you can continue going on. You don't need to worry about it. You don't have to go in there and immediately shut things down and replace things.
Yeah, I think it's not only knowing what's going on, but it's knowing what's important and what's not important, and it's about knowing what's changed, right? That's kind of, I think, the idea about observability. You hear people talk about observability a lot more than you used to, and everyone kind of has their own definition. What I like to say is observability it's not really, a product. It's not really something you buy. It's a state of being almost. It's the ability to say, I can kind of navigate backwards. I can go from effect to cause. So I can see something happen, and then I can work my way backwards through all these different sources of data, and actually find out what caused that effect. Is it because we got a lot more traffic, or because we deployed a new version that has a bug, or because this other service we rely on, isn't performing well, or did a node in our Kubernetes cluster die? So observability is really about integrating all these different things together and being able to ask these interesting questions.
So what I've gone ahead and done is I'm showing you quickly how I built a Kubernetes cluster. I showed you what's on it, the application, which is a quick kind of thing called Hipster Shop. You can Google it, and you can find it. You can Bing it, I suppose. I never say that. And then what we're doing is I showed you that there's all these different portions of the application that we can kind of take a look at. We can drill down a little. We get information about clusters, nodes, the controllers, and if we go actually into the nodes, and I think that that's probably the most interesting part here, just to kind of stretch this out, what we see is there are 3 individual virtual machines. These 3 virtual machines are essentially managed by a control plane called Azure Kubernetes Service. That's kind of what all these big major clouds we do. We throw a layer on top of Kubernetes so that you can launch the clusters and get them ready to go. And then you can go ahead, use your standardized control plane for your containers, which is Kubernetes, and send out your manifests or use your Helm charts or whatever. But the big thing you need to do and know is that still it runs on virtual machines. And like any virtual machine, you're going to need to know what's kind of going on underneath it to make sure that you've got the correct amount of resources to manage your application. And so, Austin, let me ask you a question.
Yeah.
When you talk to people about resource allocation for applications, where do you kind of get them started as far as making sure that they've right-sized what they're building for?
Yeah, that's a really good question. I think the easiest way, or not the easiest way, but the only way you're really going to know the answer is by looking at your services in production. Mm-hmm. And that's one thing that Kubernetes makes it very easy to do, especially when you kind of branch out from just basic Kubernetes and you start getting into some of the other tools that can sit on top of Kubernetes, things like edge proxies that allow you to really easily control traffic into your cluster, and then having a good suite of tools behind that so that you can kind of do experiments, right? You can say, hey, let's do an A/B test almost on our service, and let's reduce the amount of memory available to the B and see what happens to production traffic, right? Were we able to, was auto-scaling that group with less memory and actually having more instances of the service, was that a better decision than having fewer instances at a higher amount of memory? You're not going to know. You can kind of, you can figure this out. You can benchmark, right? You can create some profiles and so on and so forth. But you're never going to actually outdo prod in terms of real data. And that real data is how you should be making decisions.
Absolutely. And so I wanted to show everybody a little bit of real data, and that's why I brought this up particularly. And so this is just standard logging information from monitoring. When we have an event, we store an event, and we give you information. So this is a nicely kind of parsed out way, not just using raw logs. And I don't know about you, but I remember the days of dealing with raw logs and managing them and putting them through some sort of like way of parsing them, whether it was like using like sed and awk and then taking that it was just it was a wild west of being able to get useful information. And I feel like it had to do with the fact that the data was just so unstructured. It was just tons and tons of data thrown at you. And I feel one of the things that we've all kind of done right in our current world of technology is make taking raw data into better information to read. It's become so much easier. Like there are either a million different like logging services like Splunk or whatever, or there's native things like this. It's all out there. And one of the things that I do want to say, and Austin, it's one of the reasons why we're kind of talking about it today, is that there are things that go beyond monitoring. So like these are just standard kind of monitoring services, and Insights will give us information. So like here we see node CPU utilization, a memory, node count, active pod count, and these are great simple numbers, but they're not going to give me a little bit more real-time information that I could use for being in an SRE kind of situation, I think is the best way to put it, right, Austin?
Yeah, and I think the other thing about a lot of, and this is where traditional monitoring, has some deficiencies, is they're I don't want to say synthetic, but monitoring is telling you what the computer cares about, but not necessarily what your users care about. Because your user, the person that's sitting at home and is on their phone trying to, cop some sneakers, or is trying to transfer money, or is trying to look up an address, like they don't really care what your node pool utilization is or what the memory profile is of your application. They care, like, can I use it? Is it fast? Is it reliable?
Yeah, I think that one of the things that we've kind of learned, and I think it's a great thing to talk about, like the SRE movement in regards to this, is that SRE kind of made people understand that there was more than just to monitoring things. That we needed to kind of think a little bit beyond just how we keep things up, and the fact that like 99% or all the green and all the nines isn't always the biggest answer to our problems. And so like I think that this was a great article, and I'm going to share it in the chat. What is SRE and how does it relate to DevOps? And I think that that's going to kind of really help us key up what we're going to be talking about today.
Excuse me.
A little bit more. And so in the world of working in site reliability engineering, we take a more holistic view on how applications are kept online. And we look beyond simple things as, are all the lights green? Because all the lights can be green, but it doesn't really give you all the answers. Am I right?
Yeah, absolutely.
And so when the lights are green, but something bad is going on and we don't know about it, maybe that's lengthy database connections to actually complete an order for some sort of like store, or any of those types of things. Like when we access a web page, if it takes more than a certain amount of time, or if we access an application and loading data takes a little bit longer, the more time the user waits, the greater damage to your reputation as a website or an application is happens. And I think that's why we always talk about these things from a business standpoint. I mean, we could talk about development and software all we want, but ultimately these are business practices, DevOps and SRE.
Yeah, and also I think they're very human focused, right? I like to talk about this in the term of being unselfish. So, I want to. Right now is almost the best time to think about this in a lot of ways, because I know a lot of people are still working from home. I know a lot of people this year have had to adapt to being a distributed team, and maybe before they weren't, right? So before, you could go and you could kind of walk around the corner maybe, and you could poke someone and say, hey, I don't understand what's going on with this. Like, I deployed a new thing and I'm getting paged now and everything seems to be on fire and I don't understand why. But when you're in a distributed situation and you're working remotely, it becomes much harder to have that sort of, I can just go poke someone, right? So you need to think about how, as an SRE in DevOps and in development, how are you making this data about your system performance available to people? How are you demystifying it? How are you making sure that there's like it's democratized in terms of access? Because I might be like a mobile app developer or a front-end developer, right? And I can let's assume that I know everything there is to know about React. But I'm writing a front end to a very complex application that has tens or hundreds of services that are working in concert to do things. I might not know what's going on back there, right? But I do know, hey, someone, there's a ticket that comes in like 1 in 1,000 times, or this one particular user or one group of users is having a consistent problem. I need to be able to sort of see everything. I need to be able to know not just like, is this a thing in my part of the application, but is it something else? And what's really important about that when you are distributed is you can't just go ask the backend people all the time, right? Like, you need something that lets you see the whole application from stem to stern, as it were, and be able to kind of make your own conclusion of knowing like, oh, this is a problem that I need to tackle, or this is a problem that someone else needs to tackle.
So that leads me to kind of like what I just brought up, and I think it's really useful because you all kind of put together something I think was pretty complete. And I found this when you and I were talking about doing this show, and I thought it was really useful. We can kind of help people get a better understanding of the difference between observability and monitoring. So let's give everybody kind of a key definition of the difference, and so that we kind of get them, I guess, to a right place. So monitoring, to me, and you can tell me, I look at it like, at the top is what's going on. In the middle is keeping an eye on what's going on, and that's monitoring. At the top is kind of like our application, our traffic, all the things that happen. And I look at like the next step, kind of like we're looking at the monitoring. And we're just taking a pure look of just what's going on and making decisions just based on the information we have. The data that just says on, off, red, green, online, offline, taking 30 seconds rather than taking 5 seconds. So like we kind of can do that with monitoring. But then there's the next kind of level down, I think. When you get under monitoring, there's more information to be learned. And I think, Austin, you can tell me a little bit more about that information that we kind of get from observability rather than just going through standard monitoring. Because right here, logging data, that's only going to give me so much. Just logs in a file and monitoring of, like I said, red or green. But there's something how, like here, this is the thing I like here, and I'd love you to talk about it. Thing happened. How do we make thing happen into something that we can use to prevent a catastrophic failure?
Sure. So I think you actually have another example of that, right? Which is the structured log example. That's Apache. I think that's the Apache log format.
Yep.
I wrote this, so I should probably remember it. But what's interesting is that if you think about like how, and this is even how I write logs when I'm writing code, I usually don't have I don't have the spoons necessarily in my day to go through and make sure that I am using a structured log for everything. Quite often, I'm going to use a framework or some other tool that provides that structured log for me. So if I'm writing in C#, obviously there are logging libraries that can output things. If I'm going through like system.diagnostics, I believe there's a way to kind of create these structured log events and either put them into a log file or to the Windows event viewer or wherever. Now, that said, like I can still do a thing happened, right? And fundamentally, logs are always telling us a thing happened. But what I like to actually say, the problem with logs is their scope. So a log is only going to ever tell me what's happening in one service.
Mm-hmm.
If I only have one service, it's fine. But if I have 10 services, and now I have to like look across all 10 services logs to figure out what's going on, you start getting into, this starts to become a big problem very quickly.
So in the case of like an Azure setup, if I have a cluster of like, say, a scale set of VMs and a database that's associated with them, so that's on another set of servers. And then maybe a cache layer that we use to take care. So maybe we're using something like Redis, or maybe we're using like an old school dork like me using memcached, whatever.
Sure.
But there are all these different layers and that are kind of coupled together, or even in Kubernetes, where we're coupling these things together through pods. So regardless of whether we're using like Azure Kubernetes service, or some virtual machines, or you've got a whole bunch of servers stacked in a data center, I think that this thing right here is like the questions that we need answered are still the same, period.
Fundamentally.
Distributed applications, for the most part, always have kind of the same questions that you want to ask to ensure that they stay up. Those questions, I think, become a little bit variable when you start talking about different types of environments. So like in the cloud, the shared security responsibility, noisy neighbors is a potential, availability of services, where services are around the world and latency around them. Those are like kind of the variables in the cloud, but for the most part, I feel like we're still answering these basic questions. And so maybe we can just get to this part right here that'll help kind of key up, I guess, our next portion.
Yeah. I think at a really fundamental level, or maybe even make it even simpler, when you're monitoring something, you kind of have to know what you're interested in monitoring beforehand, right? You have to write those log statements. You have to create those metrics that you're interested in measuring. And you're writing those into your code, you're putting them on a dashboard, or you're pulling them out of a tool, right? If you're using, even if you're using Azure, right? There's a bunch of different metrics that it will make available that you can go in and build a dashboard for. But you kind of have to know all these things up front. And so you go and then you put those in there, and that causes a little bit of a stasis effect almost, where you've got if you person listening to this have ever had to deal with, OKRs or any kind of, performance measurements about your work, there's a tendency that's like when you start measuring, when a measurement becomes a goal, it ceases to be a good measurement. Same sort of thing with dashboards, same sort of thing with logs. Nobody thinks that this stuff is the cool or fun part of development. So you'll get whatever dashboard was there, and then no one ever goes back and touches it. Everyone just wants to, it's like, hey, did this thing go out of whack? Okay, let's go fix it. And so observability is really about this, active hypotheses, and you have a dynamic environment, you have dynamic amount of services, you're doing a ton of deploys, you have infinite permutations. You need systems and ways of thinking about your data, your telemetry data, that can address that.
So it's about a more like changing environment, something that it feels more like something that's alive rather than a bunch of like, I guess, automatons existing. Like an application is a bunch of kind of living, breathing things that come together, like that build eventually what we're going to have. Like anything, all these different elements that make up what we're eventually going to have, and I'm going to take off that overlay, that they're going to build a bigger product or a bigger application. And so what we're doing is we're keeping an eye on all those individual layers to ensure that our customers or our users or whatever get the best experience, so none of this comes crashing down when it's actually expected to be up.
Right, and it lets us, again, see it all from the outside, right? It lets us measure things based on how it's actually impacting users. and not just end users, right? Not just the people that are trying to use your product, but also like, your teammates are also end users, right? If you are in a big enough organization, there are other teams, other human beings at your work that depend on your code and depend on your service. So those are also end users that you need to understand their desires and their wants and their needs, and also how to make sure that your service is reliable for them, especially if their services depend on yours or vice versa, right?
So just to give you kind of all a little bit of a visibility, or I should say difference, I'm going to bring this up for a second. So I'm going to share this. So Microsoft has a document here that you can find that's just about our Azure Monitor and the information that is available. And so what I'm going to do for us all real quick is I'm going to play this, and I'm going to give Austin a chance to kind of get his demo together. And then when we get back, we will watch our demo. Okay? Let's do it. Never mind. That's way
Azure
longer.
Monitor is
That's way longer than I thought it was. I'm sorry. Okay, sorry, Austin. Azure Monitor is essentially a more about collecting information from virtual machines, from operating systems, from different resources, tenants, and then giving you ways to get insights, visualize, analyze, respond, and integrate. Now, these are monitoring specific methods of kind of handling this. But what we're going to do is kind of look beyond when we need more information than monitoring. And when we need more information than monitoring, we turn to something like observability, because it's taking a look beyond just the logging. And it's looking at more granular things that we want to pay attention to that could overall impact performance. Because ultimately, what we're doing today is we're looking for ways to ensure that our applications' performance are at the most efficient that we can provide without taxing our teams with a constant kind of pager fatigue.
Yep.
So I think that that's like another cool thing we can kind of talk about for a second. One of the big problems I noticed, Austin, for standard monitoring is that when you set up alerting around it, you don't always know what to alert for, and you end up doing alerting for everything.
Mm-hmm. Yeah, I mean that's a big, that's a big challenge, and it's actually something that I think is getting worse, not better, in particular because of bad. Let's not say bad marketing, but let's call it what it is. There's a lot of people that are going out there and saying like, hey, just buy this thing and it'll look at all your stuff and it'll tell you what to do. It'll set up alerts for you automatically, which is very unhealthy for human beings. If you look at Azure, if you look at Kubernetes, if you look at Nginx or Apache web server or any kind of database, there's so much data that our systems are emitting without us even having to do anything. And sure, you can put all that into some fancy machine learning tool and it'll spit back something at you. But these are all isolated points of data, right? Like, I don't know, for example, if I deploy a new version of my service onto Kubernetes and I see memory usage increasing on my nodes. Is that bad or is that good? Maybe I made a change that I would expect memory use to go up. And maybe I made that change because I wanted to reduce the amount of disk space being used, right? I'm making a trade-off.
This is like the old Linux conundrum of like, Linux should always use memory. Like, memory in use is good with Linux for the most part. But then monitoring sets us up for failure by saying, well, we're monitoring for, memory usage over 80%, and sometimes memory usage over 80% is good. Going into, say, your buffer and starting to buffer memory and use memory from disk, maybe that's not good. And maybe you should start alerting at points where you start seeing memory utilization actually impact other portions of the service, and maybe that's where we're going to kind of lean to next.
Yeah. So I think just to kind of start to go into towards the demo here, and we can talk more about this while I'm going through some of this stuff, because
Sure.
there's a few
Yeah, whenever
weights.
you're ready to share something.
Yeah, let me go ahead and
put it up.
switch over.
Sure. Just let me know when to add it.
Yeah, go ahead and
Great.
put it up
You
there.
might want to just pull up the resolution a little on that. Yeah. Just so
Yeah.
people can see. It's pretty tiny.
Yep.
That's a little.
So, thank you. So what we have here is, what I'm actually going to take you through today is a pretty straightforward example of setting up distributed tracing. Now, distributed tracing is a type of telemetry, and observability is really taking multiple forms of telemetry and combining them so that you can sort of see connections between things, and so you can understand your performance in your system. So what we've already done here is we already have our Kubernetes cluster on Azure. And what I'm going to use is a tool called Kate's Initializer. I will give this to Jay so he can put it in the chat.
And so is this like just a demo app that you throw up real quick?
Yeah, it's pretty, maybe 10 minutes.
Gotcha.
So what I'm going to do is, in this initializer, is I'm just telling it, hey, I want you to create an edge proxy for me, so an ingress resource in Kubernetes terms. And then I'm going to tell it that I want to use OpenTelemetry for distributed tracing, and I want to use Lightstep to do that. So I'm going to go and do a quick Lightstep account. Now this is a free account that you can sign up for as well. You get 100 gigs of data free a month to trace using things like OpenTelemetry. I need to go here. I need to get this access token. Plug it in there. All right. So what that'll do is what I'm doing now is I'm installing all of these components. I'm installing Ambassador, which is an edge resource that lets me run Envoy and do tracing and a couple other things.
All right.
It also is installing the OpenTelemetry collector, which lets me collect telemetry data like metrics and traces from Kubernetes components and also applications running on Kubernetes.
So just to get everybody up to speed for a second, the OpenTelemetry suite is a suite of tools, if I'm right, that's open source, that you can use with a number of different observability services to get you a better inference. So it's more genericized tools that can eventually be used, like Kubernetes. Kubernetes is a generic tool, and on top of Kubernetes, you can throw it on different. You can throw another layer on top of it to produce the clusters that you need. And then in this case, we're getting more information by just using an open source piece of software and then taking that information and sending it elsewhere, which is what I think we're doing with Lightstep, correct?
Yeah, and Lightstep is agnostic, right? Lightstep doesn't care where the data is coming from, what cloud, what application, from Kubernetes, from bare metal, from Azure, from wherever. Like, we will take all that data, and we're completely agnostic. Gotcha. You can get it into OpenTelemetry, you can get it to us. So we're going to do one last little bit of config here.
So on the right, you're doing a bunch of kubectl commands to apply the different manifest that's been provided to you from the Ambassador.
From the Kate's Initializer. So now that we've done that, we actually have done all the setup we need. And now, if I pods Ambassador, I see that my Ambassador pods are running, and now Ambassador is able to handle routing traffic for me.
Gotcha.
So what I should also see... Well, I won't see anything yet because I haven't deployed an application. So my next step here is I'm going to deploy an application. Now, thankfully, I already have one. So this is actually the Azure voting app, which is already on GitHub. But I have a fork of it here with some changes that I want to show real quick. Let me this up.
Yep, we're good there.
Let me actually. Cubicle. Right, so I'm going to go ahead and deploy this application, but if you're not familiar with this Azure voting app, it's a pretty straightforward little Python application that lets you vote between things, and it has a Redis backend, so you can have multiple instances of it. So what we've done to this is we've added OpenTelemetry. Now, we're adding this is just pure upstream OpenTelemetry. There's no additional components here. And the code is all annotated, but what we're doing is there's feels like a lot of boilerplate here. Now keep in mind, OpenTelemetry is still in beta. It has production beta, but we are trying to make it easier to use. So if this is something you're interested in doing, reach out. I can point you to the right places on GitHub for that feedback. We're creating a span exporter, so the traces this will generate will go to that OpenTelemetry collector we deployed as part of our K8s initializer. And then we're saying set up the tracer. And then we're adding instrumentation in for Flask, because this uses Flask for its HTTP server. And we're bringing in instrumentation for Redis, because this uses the Redis library to talk to the Redis server that we ran back over here. Now we need to do one more thing, which is we need to apply... if we check and get our pods, we'll see that it's still pulling that one, but that's fine. But we have our front end, back end. Now we need to tell Ambassador, hey, there's an application here. We want you to route traffic to that. And so that's, we have this little file here, this mapping file. So we're going to apply that.
Okay.
And then once that container creates, we should have pulling that container still.
So it's doing a Docker pull. Yeah. So it's basically grabbing from Docker Hub the image that you want to eventually load for the voting app. Gotcha.
So just taking it a few minutes. Oh, it's actually because I've never pulled this image. I made a new cluster earlier today for this demo. So that's why it's taking a while, because it's a big image, I think. But once that's done, actually, and it's taking some sweet time. So while it's taking its sweet time, let's talk a little bit about what we did, maybe, because I went really fast.
Absolutely. Let's do it. Give me a quick run through of what I just saw.
What did you see? So this K8s initializer that we first read, this is all this really does for you is this saves you from writing YAML, right? If you've ever gone through and you've tried to set up Kubernetes by yourself or adding anything to Kubernetes at all, you'll know lots of YAML. YAML everywhere. It can be frustrating. Lots of it. So what this does is this does a lot of that for you, right? So you can actually go, like everyone knows, you shouldn't just run scripts you find on the internet. So you can actually inspect all this stuff. You can actually look at the generated YAML. And what this is creating is, custom resource definitions. It's creating role-based access control. It's creating the manifest for your namespace for the OpenTelemetry collector, which it needs to have in order to receive traces and metrics. all that sort of stuff. And then it's letting you easily run them on your Kubernetes server by kind of hosting them for you temporarily, at this thing. So you can just pull that stuff into K8s and go. Excuse me. It also handles, one other nice thing that it handles is, if you've ever tried to set up, a public Let's Encrypt certificate, right, for your cluster, that can be a lot of fiddly moving parts. We can actually tell this, hey, we want to use Let's Encrypt. We want to terminate TLS. We want to have HTTPS, and we want to terminate it at that ingress proxy. So Ambassador can do that for us. And this really just makes setting up the sandboxes super, super easy, and also letting you kind of explore new things, right? Because if you can run this not only on Azure, but you can run this on, Docker, Kubernetes and Docker. You can run it on Minikube. You can run it on like a local or a bare metal Kubernetes server.
Gotcha.
Gosh.
So is that still container?
Yeah. Why is it still?
Ruh-roh.
So it's pulling. Just for.
God, I love it when you do it live. You know what I mean?
Yeah.
These are the things that we live with when we do demos live. But hey, it could be a lot worse.
It could be a lot worse. I really need to clean up my Docker images. AKS
you have a kind of a ready to go one you maybe want to show if it's not too ready to go? Completely up to you.
I can show you some historical stuff. Yeah.
Yeah. If you got a pre-built that you can show, that's super cool because I think it's just going to give us an idea, and you can just let the other one go. If we get it.
Yeah.
We got about maybe 13 minutes left today.
So let me grab a different one real quick, or just to show you some of this. Well, I gotta find the manifest file though.
I love that song. Well, while you're doing this, Austin, you got it?
Yeah. I'm working on it. But
while you're working on it, I also want to let you all know if you're watching, we will be skipping next week. There are a lot of reasons, but you can figure it out on your own. But I am going to be skipping the live show next week and no blogs. So thank you for watching this week. We'll come back the week after with some new interesting stuff. But for right now, we're talking a little bit about Austin getting his Kubernetes cluster up and running, then getting the open telemetry tools on that, and then he's going to push information from those tools, from his cluster, up to Lightstep so that he can then get some more information on what's going on.
Yeah.
Did I get it right?
You got it right. So
cool.
What we should be able to do now is hostname didn't update. That's fine. DNS. It's always DNS. So if we do this, we deployed another service that is much smaller.
Mm-hmm.
Theoretically, well. All right.
Okay.
We have our external IP address. Great. So now, this backend. All right. So we have an application running, and this is just a very simple one. This is just going to give us a quote, right? And I can prove this to myself. in the ambassador namespace, and yeah, you see this quote pod right here. So if I go back to Lightstep, did it finally actually work? Oh, hey, the other one's actually running now too. Great. Well, that's good. So we can actually go and show this certificate error, whatever. Now we have our Azure voting app, right? So I can say cats or dogs. Do you vote for dogs or cats?
Of course, I'm a dogs guy. Your
Dogs.
little one's a cat, my little one's a dog.
All right, so we're going one to one, cats and dogs. If anyone in the comments wants to pipe up. So now you should notice a change in Lightstep here, right? Like suddenly there's stuff. And what is this stuff? So you didn't have to configure anything, right? You saw like all I did was put in that access token from Lightstep into my OpenTelemetry collector configuration. Now, automatically, Lightstep is actually, what happens there is we're starting to get traces from, let me actually expand this. Oop. There you go. Make it full screen. We're starting to get traces from multiple components. One, we're getting them from Ambassador itself, which is that edge proxy. We're also getting them from our Azure Vote application because I instrumented that with OpenTelemetry. And we can see that Lightstep has automatically started to figure some stuff out. We have very limited data because we've only seen this for a couple of minutes, but you can see like we're starting to calculate what's the P50 latency, how many errors are we seeing off that service, what's the rate of operations.
And let's talk a little bit about that in context of what we were talking about, like service level objectives when we're talking about SRE stuff and service level indicators. Like these are things that you can use to help set those kinds of things. And if you need to get more information on them, go check out the SRE book, look up SLA, SLO, SRIs. These are all really great indicators on whether or not your application is performing at its best. And you can use things like how long, you can ask this question and tell me if you think this is right, Austin. Mm-hmm. For this particular voting app, how long does it take to actually store the vote? And if the vote storing takes more than, say, 5 milliseconds or something stupid like that. I don't know.
Well, that's a great question. Right now I am actually getting some more data into this so that we can see. Yeah, I only see your browser. Okay. Yeah, I was doing it in another window. So that's a great question though. Like how long are things taking? So let's go into our data explorer, right? Now, once I'm in here, I can start to query my data, right? I can start to ask questions. You'll see down at the bottom, we have all of these different traces. And you can also see the service diagram, which shows us, the relationship between things. We have our ambassador service is sending requests to our vote service. But let's start to kind of narrow this down and look at what you were asking. So I'm actually going to group this into... let's group it by operation. So this is this is actually what is this is the actual operations happening. This is that the span is being created for, that this trace is monitoring. So we can see we're probably interested in one of these, Redis calls, right? So if we go into here, we can see like how long did each of these Redis commands take, and if we jump into that. And, just to make sure that we're kind of looking at the right thing, we can see the entire request from where it comes into our cluster. This is where it's being... Technically, there's one step removed here. There's a level 4 load balancer on the Azure side that's forwarding traffic to our front end, or it's receiving, it's sending it to this service or to this IP address. Or this IP address is listening for it, and it's sending it to Kubernetes through that load balancer. But this is where it goes into our edge proxy. We can see it doing an authentication step, which everything's authenticated, so there's no,
And this, just to remind everyone, this is using the standard voting app for Azure. Let me find that Azure voting app.
Yeah,
AKS.
there's a fork of it that I have that has the open telemetry code in it, but
This is the actual tutorial right here.
yeah.
Let me share it for everybody. If you want to actually use the Prepare app, it's right there, that tutorial.
Yeah. So what I want to point out is we went from our ambassador. If you see how the names are changing here, we're going from ambassador to Azure vote. So this is actually crossing a service boundary, right? This is going from Envoy and it's going into our Python code. And we didn't have to manually instrument this. We just had to do one line of code that said instrument Flask, and now we have all this other stuff. So I can look at this and I can actually see where is time being spent. It took 5 milliseconds for it to run index. And I can see specifically, here's how long each of these Redis commands took. And we can also visually confirm some interesting things. One, these Redis commands are actually happening in parallel. They're not serial. You can see how, if I click on this, how they're all kind of stacked like that.
Sure.
Or at least these two are. This black line here tells us the critical path. So we can see that we're actually, they're all three happening effectively simultaneously, but this is what was actually took the longest. And if we look at the statements over here, this increase dogs 1 took longer than the get cats get dogs, which kind of makes sense, right? It probably takes longer to write than it does to read, especially on something like Redis. And now if I want to see this across multiple things, let's do some more filters and groups. Let's explore our data a little bit more. So that was let's filter to just Redis. And then let's group by statement. And now I can see right here, what's the average latency for each of these statements? So I can ask, say, the quickest one.
And so, once again, it's more about answering questions than it is how to solve problems. It's asking the questions before they become problems.
Right, and because you can ask these questions, like we just went with no, and I want to say, with all open source software, right? Like none of the tools we're using on the back end here are proprietary or closed source or require you to pay money. And this Lightstep account, if you're using this for kind of these purposes, for development, for dev environments, is 100% free. We'll never ask you for money for it. And the Azure credits, they give you $200 of that, right? The links in the bottom.
Free credit
right down there.
Yeah, and 12 months of service. So while you're kind of using that, you get like 12 months of free services plus the money, so you can kind of figure out both at the same time. But anyway,
but with all this free open source stuff, we're actually able to ask like really interesting questions about. Yeah, it's a simple application, but you could do this. This works on any Redis statement, right? There's also plugins for your normal SQL servers. So if you have like, hey, what SQL query is taking the longest? Right here, I can ask that question super easily, and I can see that it actually took, on average, a little longer to increase dogs than it took to increase cats. But we can also see, get takes about the same amount of time as, reset. And I can keep going from there, right? I can do more and different groupings. I can also do other interesting stuff. Like I can say, show me kind of what's going on up here. This is a histogram of latency. And we will automatically look at that sort of data and find things that are highly correlated in it for you so that you can, use that to kind of go in and do these investigations and go through and like parse through your data.
Gotcha. So, hey, Austin, we've kind of run to the end, man. That's
good timing.
An hour.
Wow.
And we did so much. You and I end up, we do a podcast together, and every week we talk a lot for an hour, and it's insane. We do it at least once a week, but we never talk about things like this.
That's true.
And so I'm super, super lucky that today you gave me some time to talk about observability and using Lightstep on top of Azure Kubernetes Service. So Austin, what do you got coming up soon? Anything interesting? Any more conferences? Any live stuff?
Yeah, so the big thing I got coming up is next month at KubeCon North America Virtual, which will be around the 17th of November through the 20th. I'll be doing some stuff around then. If you're interested in OpenTelemetry and you're going to KubeCon, check out OpenTelemetry Community Day. It's on that Tuesday, the 17th. It's like $20, I think, to add onto your KubeCon ticket. But it's going to be an unconference. It is going to be just a big discussion-focused state of there'll be a state of the community. There'll be the history of OpenTelemetry. A lot of great, just like people that are using it, people that are learning it, people talking about what they want to do in the future with it. A lot of great discussions, very much not like your traditional virtual conference. We don't want you to just feel like you're staring at a Zoom all day. So very interactive. I think it'll be a ton of fun. I hope to see everyone that's interested in it there.
Austin, thank you so much. I will see you next week for our podcast. That's going to be, we don't even need to get into it.
Yeah.
But everybody who's watching, thank you very much. We're going to give you a big wave goodbye. We'll be back in 2 weeks. That's right. AzureFunBytes will be back in 2 weeks. We're going to take next week off. Really, really glad that I got to spend some time with you, Austin. Hope you and everybody you got in your home have a great weekend. I will talk to you soon, all right?
Right back at you. Thanks so much, man.
Thanks, Austin. No problem. Hey, everybody. Once again, this is AzureFunBytes. My name is Jay Gordon. I will see you next time. Thanks again for being part of this. I always really appreciate it. See you next time.